Hey, everybody, and thanks for joining me to 9.1. Today we'll be discussing statistical measures and statistics. Section 1 is just an introduction to statistics, and I hope you can find something a little bit interesting in statistics because there's a whole field dedicated to statistics. If you wanted to go to college, uh, for statistics, you could. There's a lot of companies out there right now that are looking to hire students and people who know and have a good base on statistics. Let me give you one quick example of that here in this AWS. It's an Amazon series. They use statistics for this sports example. Let me play it a little bit.
Ran down in the first. Nick Foles was about to complete one of the most improbable plays of the game. With each tick of the clock, AI from Amazon Web Services processed thousands of data points to generate real-time insights, proving that a 19% chance was all Foles needed to change the course of history.
So that's just one example I like to give students of statistics and probability. And a lot of companies are starting to use this information to help them. So lots of different examples we'll see today, and I hope you can find one that you can relate to. For our learning target, we have I can recognize statistical questions and use dot plots to display numerical data. All right, starting with a little bit of vocab. Statistics, what is it? It's the science of collecting, organizing, analyzing, and interpreting data. Wow. Collecting, organizing, analyzing, interpreting data. A statistical question is one for which you do not expect to get a single answer. Instead, you get a variety of answers, and you're interested in the distribution and the tendency of those answers. So, really, when we're looking at statistical questions, we're seeing a variety of answers, so that's what we expect, and we're looking at the tendencies of those answers. So it's really kind of breaking down data and breaking down numbers and actually what do they mean in the context of the problem. Last little reminder here, recall that a dot plot uses a number line to show the number of times each value in a data set occurs. Dot plots show the spread and the distribution of a data set. So let's see one of those examples. It says you conduct a science experiment on house mice. Your teacher asks you, what is the weight of a mouse? So letter A asks, is this a statistical question and can you explain it? Well, again, I like to go back to the definition, and is it a question where I don't expect to get a single answer, but more a variety of answers? And does each mouse weigh the same? Definitely not. So because you can anticipate that the weights of mice will vary, it's a statistical question. It is a statistical question. Obviously, not every single mouse is going to weigh the same way, and you're going to get one answer. You're going to look at the data of probably a lot of different mice and then maybe average, or then maybe find the range, or you're going to dig a little bit deeper into those numbers. So letter B says you weigh some mice and then you record the weights in grams in the table. So here's that table we're talking about. Display the data in a dot plot and identify any clusters, peaks, or gaps in the data. All right, so remember a dot plot uses a number line. Here's my not so straight number line. And I'm going to look at my data and see, what's my smallest number? What's my biggest number that I need to graph? So I know kind of by what increments I need to go by and what I should start my number line at. So here I see my smallest number is 18. And that's the smallest number I see. So I'm going to start at 18 will be my first one. And what's my biggest number? I got a 28. Looks like 28 is my biggest. So I should be able to fit 10 on here going by ones. So I'll just go by ones. 20, 21, 22, 23, 24, 25, 6, 27, 28. Okay. And once I'm done making my number line, then some people do circles, some people do X's. I'll just do X's, but it doesn't matter on your dot. I guess it is called a dot plot, so that's why some people do dots. Like I'll show you an example. Here, 18, they put a dot like this. But since my pen, whenever I make a dot, seems to like to erase, and I haven't figured out that setting, I'm just gonna make an X. But it works the same. I've got a 19. I've got two 20s, so 20, 20, and a 28. I just like to go by columns just so I don't forget any. 19, 20. Okay, 19, 20, 23, 21, 23, 21, and a 22. Can be a little tedious, but you'll see it's nice in the end because you can quickly look and see the data. It's 27, 20, another 18, and a 21. Then I got 20, 21, 20, 21, 19, 27, 19, 27, and finishing up with a 20. All right, so there is my data displayed in a dot plot. And next I need to identify any clusters, peaks, or gaps. So peaks would be like the highest point, just like on a mountain. So I definitely have a peak at 20. So I have a peak at 20. And then I have a cluster. A good amount of my data, I would say, is clustered from 18 to 22. So clustered from 18 to 22. I'd be confident in saying most of the mice that I weighed were in the range of 18 to 22 grams. And then lastly, gaps. Do I have any gaps in my data? Well, you can look here and there are three numbers that really show gaps. So from 23 to 27, anything bigger than 23 and anything less than 27, there is a gap. So that's all it wants us to do. It wants us to plot it on a dot plot and then identify clusters, so where a lot of your information is, peaks, so where some high points are, and then gaps, where there aren't any information. Okay. And lastly, letter C, it says use the distribution of data to answer the question. What is the weight of a mouse? And I will look at this data, and it definitely clusters from 18 to 22, and the peak is at 20. So I'm going to say most mice weigh about 20 grams. All right. Why don't you try one on your own that is very similar to that? Please pause the video now and then come back to check and see if you get it right. Okay, I went ahead and started with the on your own here. The table shows the ages of some people who retired early. you are asked how old are people when they retire early? Well, first thing we need to think about is this a statistical question? And then explain. Well, I said, because you can anticipate that the ages will vary, it is a statistical question. Remember, a statistical question is one for which you do not expect to get one single answer, but you expect a variety of answers. And that's what we do have in this chart here. So, yes, it is a statistical question because we can get some varying answers here. Letter B, display the data in a dot plot. So I made my number line and then graphed each one of these ages with an X. And then to identify the clusters, I see a cluster from 58 to 62. A peak definitely at 60 is my high point in the mountain here. And then gaps. It looks like I've got gaps from 56 to 58. There's a gap. There's also a gap from 62 to 64. Another kind of gap there. So then it says, use the distribution of the data to answer the question, how old are people who retire early? So it looks like I have that peak at 60, and most of my data is clustered around 60. So I'll say most of the people, most of the early, I'm going to say retirees were about 60 years old. They had that peak in that cluster around that age. Let me know if you have questions on that. Example 2 now is they give us a dot plot right away, and you'll notice that this dot plot is actually a vertical number line dot plot, and it's shaped like a thermometer because what are we talking about here? The high temperatures every day while at summer camp in August. All right, so you record the high temperature every day while at summer camp in August. Then you create this vertical dot plot. The first question says, how many weeks were you at summer camp? Well, we could find that by counting each dot because we know that these dots represent the high temperature every day. So how many dots do we have here? 4, 5, 6, 7, 8, 9, 10, 11, 14, 15, 16, 17, 18, 19, 20, 21, 2, 3, 4, 5, 6, 7, 8. So it looks like we have 28 days, but this question wants to know weeks. Again, we found this by just counting the dots because it stood for each day we marked the high temperature. So each dot counts as a day. To find the number of weeks, well, there are 7 days in a week. So if I divide this by 7, that would give me 4 weeks that we were at summer camp. All right, 4 weeks in August, pretty much all of August. Letter B says, how can you collect these data? And what are the units? Well, you can collect these data with, how do we know this? Well, we can use a thermometer to gather our data or to collect our data. And these units here that we're talking about are degrees Fahrenheit. Fahrenheit's weird, Fahrenheit, or abbreviated with the little circle, capital F, degrees Fahrenheit. And letter C says, write a statistical question that you can answer using the dot plot, and then answer the question. Okay, there will be a variety of questions that you could answer or that you could come up with for this data here. But we're talking about in our directions, we're talking about high temperatures every day. So my question would be, what is the daily high temperature in August? What's the daily high temperature in August? Now, remember, if it's a statistical question, we shouldn't get just one answer. And if I'm looking at my data here, I can see that about half of my temperatures are clustered around this 81, and the other half are clustered around this 86 mark. We actually have a couple peaks in our data here. So if I were to answer that, I would say, what's the daily high? Well, it's spread out, and half of my data is around the 86 degree mark, and the other half is around the 81 degrees Fahrenheit mark. So my data is kind of split here, but again, that's a normal finding. We don't expect for there to be just one single answer. All right, end today with the second on your own in the ABC here. Please pause the video now to try it out yourself. All right, letter A, counting the dots. This dot plot shows the times of 6th grade students in a 100-meter race. So the number of students is the number of dots, and there are 20 of them, 20 students. How can you collect these data, and what are the units? Well, I know one way to collect data on timing a race is to use a stopwatch. And what would the units be in? Well, in seconds. If I'm talking about a 100-meter race here, 13 seconds and so on sounds like a reasonable unit to use. So seconds. And then letter C says, write a statistical question that you can answer using the dot plot. So again, here we write a question, and my question would be, how long does it take a 6th grader to run 100 meters? And that's what this is about, 6th grade students running a 100-meter race. And then answer it. I would say it takes most students around, most of my data is clustered here, and this is at 13.8. So around 13.8 seconds to run 100 meters. All right, there you have it. This was just a little introduction to statistics, looking at some data, looking at some questions, and going from there. Please let me know if you have any questions, and this will do it for 9.1.